In part 3 of the MU calculation, we talked about the beam profile. We described an open field profile and the wedge profile, and how the toe and heel of the wedge affects that beam profile. This ties directly into the off-axis ratio part of the monitor unit calculation equation. So if the physician or you happen to want to calculate the dose to a point that's not on the central axis, we need to apply an off-axis factor, or called an off-axis ratio. And all this is it's a ratio of the dose to a point off of the central axis. We'll call this point A, and we're going to take it to a ratio that to the dose on the central axis. So if I had off-axis factor for point A, it's going to be dose at A divided by dose at the CAX, the central axis. And that's all it is. Note that this is going to be greater than 1 for an open beam, because everything is normalized to 1.0 on the central axis. So off-axis factor equals 1.0 on the central axis. For an open field, it's going to be roughly plus or minus 3%, the entire length of the field. Not the case in the wedge field. So the wedge field that we drew earlier, if this is the wedge orientation across the beam and we scan left to right, this is the profile that we create. Now there are some general rules of thumb that we can use to describe how much that off-axis factor is going to be. For a 15-degree wedge, for every centimeter that you go off-axis, you're going to increase or decrease roughly 1 to 2%. For a 30-degree wedge, 2 to 3% per centimeter. 45-degree wedge, 3 to 4% per centimeter. 60-degree wedge, 4 to 5% per centimeter. Remember, this depends on the wedge and the machine that you have, but these are just general guidelines to go by. So if I move 1 centimeter toward the toe with the 60-degree wedge, I'm going to be 5% hotter than I would on the central axis. If I move 2 centimeters towards the toe, because of the greater attenuation, I'm going to be 2 times 5, 10% hotter. So how does the off-axis factor work with this? If I have point A, and point A is 1 centimeter from the central axis, and if I follow this general rule, my off-axis factor is going to be my dose at point A, call it 105, divided by dose at the central axis, so 1.05. Again, with the monitor unit equation, everything is relative. Everything works in fractions. So it's a dose in centigrade divided by a bunch of fractions, or percentages. This is my off-axis factor. If I go off-axis the other way, towards the heel, let's say to point B, my off-axis factor for point B is going to be 5% less, is 95, divided by the dose on the central axis, which is 100, and I'm going to get 0.95. Okay, so I'm 5% cooler off-axis toward the heel, and 5% hotter toward the toe. Off-axis factor, again, accounts for the change in the intensity of the beam as we move off the central axis of the beam. Okay, it's particularly important for wedged fields.